In this video, we're going to work out examples to solve quadratic inequalities. Example 1 says solve the following quadratic inequalities. Represent your solution in interval notation and sketch the solution set. We're going to let p of x equal x squared plus x minus 2 times x minus 3. Find where p of x is less than or equal to 0. Or we could think of this as x squared plus x minus 2 times x minus 3 is less than or equal to 0. It's already been set equal to 0, or everything, all the factors have been put on one side, so we can now see if this x squared plus x minus 2 factors. It will factor to x plus 2 times x minus 1 times x minus 3. That is less than or equal to 0. So we have three factors. These binomials can represent zeros or roots of a polynomial. So I'm going to put notches on my number line where these points would be. If I set each one of these binomials equal to 0, I would have x equals negative 2, x equals 1, and x equals 3. So I will put negative 2 as one point along my number line, 1, and 3. Since I have no denominators, I don't have to restrict my inequalities by anything. And since this says p of x less than or equal to, we put a closed dot at each one of these interesting points or zeros of the polynomial. I also know that because of the leading coefficient being positive, the x squared is positive, I know that I would have 3 roots, degree 3, and it would look something like this if I graphed these 3 binomials. It would have a cubic shape. Because of that, I can see by inspection where my function is less than or equal to 0. I will put little less than signs all along my number line where the curve is below the x-axis, and I'll put little plus signs wherever my curve is above the x-axis. Curve is below the x-axis from negative infinity to negative 2. It's above, the curve is above the x-axis from negative 2 to 1, and it is below the x-axis, or negative, from 1 to 3. And again, it is positive or above the x-axis to the right of 3, so from 3 to infinity. If I look at this, I can clearly see where my polynomial p of x is less than or equal to 0. So I would write this in interval notation. Wherever there was an interval that was negative, I would give the interval here. Negative infinity to negative 2. I put a bracket because it's a closed dot at negative 2. A less than or equal to, a closed dot, and a square bracket represent including or equal to parts. I'll put a union because there's a gap here where the curve is positive. I'll put a bracket because now it's less than or equal to again from 1 to 3. Another bracket. And since the curve continues off into positive territory to the right of 3, I stop here because we're only looking for values of the curve that are less than or equal to 0. There is one other way you can solve these, or find the intervals. You can do that with signs, and I'll show you how you can do that with signs. This is with a graph. This will be without one. We know that our roots are -2, 1, and 3. We know that it's including those points. So we pick values between -infinity and -2. We pick a test value between -2 and 1, and we pick a test value between 1 and 3, and then a test value from 3 to infinity. So I'm going to use a test value of -3, a test value of 0, a test value of 2, and a test value of 4. If I do that and I plug those values into my polynomial, I would have -3 plus 2 times -3 minus 1 times -3 minus 3. That would give me a negative, negative, negative. This would give me a negative overall result. And if you compare that with what I had up above, it matches. Now I'll plug in 0. If I plug in 0 for x plus 2, I will get 2, or a positive. 0 minus 1 is negative. And 0 minus 3 is negative. When I multiply those together, I will have a positive overall result. If I substitute 2 in, 2 plus 2 is positive. 2 minus 1 is positive. 2 minus 3 is negative. And when I multiply those together, my overall result will be negative. If I substitute 4 into my polynomial, I will have 4 plus 2 is positive. 4 minus 1 is positive. And 4 minus 3 is positive. And my overall result will be positive. And the intervals will match. So you can decide which one you like better, which method. Do you like the method with substituting values in and finding where the table of values is positive and negative? Or do you like the method where you draw a sketch of the shape of the graph, which is also okay? Remember that the drawing shape of the graph and then finding the interval on which it is true will be the most helpful moving forward in this course.